Hello guys, welcome back. In this video we're gonna do one conceptual problem on acceleration and velocity, and since the next video we're gonna move on to kinematic equations. Okay, so let's proceed with this conceptual sum. Now this sum has two parts, A and B. The first part states if the velocity of an object is 0, does it mean that the acceleration is 0 as well? Okay, and the second part is if the acceleration is 0, does it mean the velocity is 0? Okay, so let's first start with the first part. If the velocity is 0, does it mean the acceleration is 0? Well, what is acceleration? Acceleration is change in velocity over change in time, right? Rate of change of velocity is acceleration. So change in velocity, delta v, that is over change in time, that is delta t. Now, if the velocity is 0, that is the velocity is 0. If the velocity is 0, then the change in velocity is gonna be 0 as well, isn't it? That is, if the velocity is always 0, then the final velocity and initial velocity are gonna be equal, that is 0. Then the change in velocity is gonna be 0 minus 0, right? Delta v, that is v final minus v initial, that is 0. V final is 0, v initial is 0, so it's gonna be 0. So delta v is gonna be 0. So this is gonna be 0 over something, so it's gonna be 0. So yes, if the velocity of an object is 0, the acceleration is 0. This is right. Okay. You don't actually have to do the maths over here, you can just imagine it physically. If the velocity is 0, that means the object is not moving. Then if the object is not moving at all, of course it's not accelerating, right? It's not moving at all, it doesn't have any velocity, so acceleration is ought to be 0. It's at rest. Okay. Now the next part, if the acceleration is 0, does it mean the velocity is 0 as well? Okay. Now again, what is acceleration? Acceleration is delta v over delta t. Right? Now, if the acceleration is 0, that is, we have been given that this is 0. So 0 is equal to delta v over delta t. Now, does it mean the velocity is 0 as well? Okay. Now, this quantity is 0. If a fraction is 0, that means the numerator has to be equal to 0, right? Therefore, this quantity is 0, therefore delta v must be equal to 0. Right? Denominator cannot be equal to 0. If the denominator is equal to 0, the whole quantity is going to be infinity. Right? So the numerator is going to be equal to 0. So delta v is going to be equal to 0 if acceleration is 0. Now, when is delta v equal to 0? Well, there are two conditions. There are two conditions where the velocity, if the delta v is gonna be equal to 0, then there are two possibilities. The first possibility we discussed in the first part, that is velocity is gonna be equal to 0. That is, if velocity itself is 0, of course delta v is gonna be equal to 0. But there is a second possibility as well. What is delta v? Delta v is v final minus v initial, right? So if v final is equal to 0, is equal to v initial, that is, there is no change in velocity, still the delta v is going to be equal to 0, right? So the second possibility is v final is equal to v initial. Although these two, v final and v initial, are not equal to 0, unlike this case where it is, here these two quantities are not equal to 0, but still if vf is equal to vi, then the delta v is obviously going to be equal to 0, right? Okay, so if vf is equal to vi, that is the acceleration, then delta v is going to be equal to 0. Hence, the acceleration is going to be equal to 0. So there are two possibilities. The first possibility is if the velocity is equal to 0, right? So it is one of the possibilities, but not the only possibility. The second possibility is if the velocity is not changing at all, that is v final is equal to v initial, then too the acceleration is 0. What is acceleration? It's rate of change of velocity. But if the velocity itself is not changing, if the velocity is constant, what does this mean? This means that the velocity is constant, right? Vf is equal to v initial, that means velocity is constant. So if the acceleration is 0, there are two possibilities. First one is the body is at rest, that is v is equal to 0. If v is equal to 0, then the body is at rest. So the first possibility is the body is at rest, and the second possibility is the v is constant, velocity constant. So the body at rest, that is the velocity is equal to 0, is one of the possibilities, but it does not necessarily mean that the velocity is always 0, right? The velocity can be constant and acceleration still can be 0, right? So if the question has necessarily, then it's gonna be false. It does not necessarily mean that the velocity is 0. It can be constant as well, right? So alright, that's it for this video. As I said, in the next video we're gonna start with kinematic equations. Alright, if you have any doubts or any questions regarding this context, okay, make sure to just put the questions in the comment box. Alright, okay, I'll see you guys in the next video. Thank you.